cardinality of a set. Cardinality of a set. I'll give you some examples. That's the symbol for cardinality. Okay? So what cardinality does is it takes a set, it's an operation that takes a set and gives you a number. And this cardinality operation, the number it gives you here is 2. If the set contains just A, B, C, and D, it gives you 4. If it contains the letters of the alphabet, it gives you 26. So what's the cardinality of the set? The number of elements it has. So what's the cardinality of the empty set?
0.
Right. Okay, so here's a set. Let's call it R. And now I want to know what's the cardinality of R?
3.
That's why I gave it to you, because it's confusing.
4.
Okay, so what's an easy thing to deal with? What? PQ? What?
For sure.
Yeah, okay, how can we simplify this expression? Let me put it down. What? Eliminate the repetition of P, right? That doesn't affect cardinality. It's not how many symbols are here between commas, it's how many things are there about which I can say, yes, you're in the set, without repeating myself. Okay? So it's at most going to be 4. Okay? And now I'm trying to trick you, or I'll come back to the question that came up before, right? The elements of this set, okay, there's definitely Q, there's definitely P. What is this?
Which one?
This one here.
The
It's the empty set. It's a set. It's a thing. Okay? If we want to go back to our box analogy, I reach inside R and I can grab a Q, I can grab a P, I can grab an empty set. It's an empty box. That's it. Okay? So there's one thing, there's 2 things, there's 3 things, and then this is yet another one. It's the set that contains the empty set. So it's another box inside R that has another box in it. So it's actually 4. Okay? The cardinality of this thing is 4. Okay? So cardinality is just the number of elements in a set, the size of the set. Okay? So if I tell you something like this, let's make subset. T is a subset of S. What can you tell me about the cardinality of T and the cardinality of S? Everybody see this? Jenny, you see it? Yeah.
The cardinality of T has to be less or equal to the cardinality of S.
That's what every reasonable person would say, right? And for our purposes, it's going to be true. Okay? But the cardinality of T is going to be less than or equal to the cardinality of S, right? If they're equal sets, then it's going to be equal. If it's a proper subset, then it's going to be less than. Okay? The power set of A. It's all the subsets. So it's every subset of A, which is going to include A itself, the empty set, and maybe some other junk. We got to see. So let's say A is the set that contains just X. And now let's do the power set of A. Okay, first thing is I make my big brackets, because I want a set of subsets. And then I'm nice and orderly, so I'm going to start with the biggest set I can. The biggest subset of A. What's the biggest subset of A? Yeah, A itself. I'm going to write it out. It's just the set that contains X. And I'm going to go all the way down to the null empty set, which is the smallest possible one. And there's nothing else you can do. Right, Raquel? There's nothing else to play with. Right? So that's it. Okay? So what we've seen is, okay, let's keep going. Let's do this. Let's take B as x and y. So we want to do the power set of B. And so Sinette, here's B. We're going to go from B itself, which is the biggest subset, right? So what's B itself? Just read it off to me.
X and Y.
Let's be like super pedantic, like the set that contains x and y.
Yes.
Okay? So the set that contains x and y and nothing else. And just so that we know that the end is in sight, what's going to be the smallest one?
The empty set.
Perfect. And now give me some other ones, the intermediate ones.
The set of X.
The set that contains just x?
Yeah, and a set that contains just Y.
Beautiful. There you go. That's the power set of B. Okay? So don't forget the end ones are easy. Don't forget the intermediate ones. This is where everybody, for some reason, people are fine. As soon as we go to C equals the set that contains x, y, and z, or z, as you guys say, let's do the power set of this. It's the biggest subset you can have.
X, Y, Z.
Right? So the,
Subset.
the set that contains x. I should have you come to the board, but I'm running out of time. Good. And let's go down to the end. What's the smallest one? Smallest. What's the
Empty set.
The empty set? Yeah. I'm going to write it this way just for variety. Okay. So I got the sets. I got the subset that contains 3, cardinality 3. I got the set that has cardinality 0. What else is there in between 3 and 0? 2. So what sets can contain 2 from that are subsets of C? So they have to be a subset of this that have 2 members. The set that contains, say it.
The set that contains X and Y.
Yeah, that's one of them. I'm going to write them vertically. Just to, okay, what else?
And then the set that contains Y, Z.
Yeah. And then there's one more.
And then the set that contains Z.
No, one more with 2.
X, Z, sorry.
There you go, X and Z. I told it. Okay. Now we got the ones that have cardinality 3, the ones that have cardinality 2, the ones that have cardinality 0. What's left?
1.
Cardinality 1. So what are they? Talia. Talia, just.
X, Y, Z.
All right. I'm going to write X, Y, Z. No. 0 points. You failed the class. You're terrible. Terrible person. No, now fix it. Fix it.
Sorry,
So you got the subsets of C that have 3 members, the subsets of C that have 2 members, the subsets of C that have 0 members. These are not sets. A subset is a set. How do I make these into sets?
each individually.
Yeah, so the set that contains,
X.
the set that
The set that
contains,
contains Y, and then X. The set that contains.
there you go. So I, blah, 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 blah. Okay? All right, so how many are there? 1, 2, 3, 4, 5, 6, 7. Wait. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So the cardinality of this thing, cardinality of power set C equals 8. Okay, so when we started with the empty set, okay, what's the cardinality of the empty set? 0. What's the cardinality of the power set of the empty set? It was 1, just the one that had the set that contained the empty set in. What's the cardinality of our set A? Is it still there? Yeah. What's the cardinality of A?
1.
What's the cardinality of the power set of A?
2.
Okay. What's the cardinality of B?
4.
B.
2.
It was X, Y, right? 2. What's the cardinality of the power set of B? No.
4.
Where is it? Is it here? 1, 2, 3, 4. Okay. 4. What's the cardinality of C?
3.
And what's the cardinality of the power set of C?
8.
Okay, do you see the pattern? If the cardinality of A equals n, then the cardinality of the power set of A equals 2 to the nth power. Tricked you into doing math. Okay? So 2 to the 0th power is 1. You might not remember that from grade 7 or whatever. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. So you already know, if I say here's set Z that has a cardinality of 17, then what's the cardinality of the power set of Z? I'll try to say Z. Equals 2 to the 17th, which is a lot. Okay? Okay? But do not remember this. Do not remember it. I demand that you forget it right away. Okay? What? But you got to remember instead how to figure it out again. You say, I'm making some subset. I got to look at the original members, and I got to decide if I want them in there or not. So if I want to take this set here, and I want to get the empty set, I can think of the empty set as saying, okay, what's in here? Nope, nope, nope. Right? So I can think of this as like no, no, no. And I can think of what's the biggest subset of C? C itself, right? So it's this one. And I can say, okay, it's x, y, z, but I can think of it as, yep, x is in here, yep. And, how do I do this with commas? I'm just going to do it. Okay. Y is y in here? Yep. Is z in here? Yep. So yes, 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 all the way down to no, no, no. So let's start with some of the others. I could get, okay, is x in here? No. Y, yes. Z, yes. Then that would be the set that has y and z. And then I could do, how about the set that's equal to x and z? That would be yes, no, yes, and so on. Right? And so if there's n members, I've got a yes-no question about this guy, and a yes-no question about this guy, and a yes-no question about this guy. And so however many members I have, I've got that many yes-no questions. I get 2 choices, times 2 choices, times 2 choices, and if there was more, A, B, C, blah, 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 I'd have 2 choices, 2 choices, 2 choices, 2 choices, 2 choices, 2 times 2 times 2 times 2 times 2 times, which is the number of things I had, which is 2 to the n. That's why the cardinality of the power set is 2 to the power, which is the cardinality of the original set. So we said in a set, order doesn't matter, right? Like an AB is the same thing. It's exactly the same set as GA, right? But in general, when you have information or numbers or whatever, the order does matter. Martin Luther. Let's say Martin Luther. Okay, Martin Luther is a different person than Luther Bond. Okay? Right? The order matters. Okay? Or if you're on a coordinate system and I say, go, 1, 2, 3 steps that way, what's that, east, and 2 steps to the north, you end up here. So if I say go 3, 2, it's different than if I say go 2, 3, in which case you end up here, right? 2, 3, 2 doesn't equal 2, 3. Okay? So a set with 2 members is different from what's called an ordered pair of numbers, an ordered pair. Order matters in an ordered pair, which is why it's called an ordered pair. Okay? And then we could have even more. We could have, 5. If we have 3D space, right? Imagine we have a 3rd dimension. We could have locations that are 2, 7, 13. An ordered triple. And obviously repetitions can occur because the point 2, 2, go 2 here and 2 here is over here. You can repeat numbers in ordered sets. Okay, so an ordered set or an ordered pair is another possible mathematical object. We're not going to use them very much. Actually, I'll tell you, we're going to get to features, and we're going to have things like plus voiced. And we're going to treat these as ordered pairs. There's a value and an attribute, or a feature and a value. And we don't want to be writing, like voiced plus. right? Plus voice versus minus voice. We need to keep things in order. So there can be two different kinds of things, but the order is going to matter. So ordered pairs or ordered triples, sometimes they're called, there's a general word for them, which is tuples. So like a double, a triple, a quadruple. So the general term is an n-tuple, or just a tuple, or a tuple, a tuple. And there's two notations. Sometimes people use parentheses, but we're going to use the angle brackets. So A, B, like this, is different from B, A, which is different from the set that has A and B. Okay, so those are tuples. So we'll use those a little bit. One way that you can think about using this right away is kind of silly, but if we think about what are words or what are morphemes, they're phonological representations, we can think of strings of segments as tuples, right? So if I say, I'm thinking of a word or a morpheme of English, and it's got a k, it's got an a, and it's got a t. What morpheme am I thinking of? Wrong. I was thinking of tack. Okay. Let's try again. I'm thinking of a morpheme of English, and it's got a k, an a, and a t. What morpheme is it? What? Well, is it cat or is it tack? Wrong. It's act. So we can represent morphemes or words as ordered sets of, so this is different from a, k, t, which is different from ta, t, k, right? So it kind of gives us a way of formalizing the idea of a string as an ordered tuple of segments. Okay, and obviously, like, you know, repetition's possible, right? Because what's this? This is what word is this, or what morpheme is this? New, right? And that's different from noon, right? Noon versus new. They're different words. This has a repetition in it. Okay, so we'll have some use for these. So words are not just, so morphemes are not just sets of segments. They're ordered sets of segments, or tuples of segments, or strings of segments.